Welcome to lecture 13 about system design. The first question is to improve the efficiency of the whole PV system by the planning procedure. The designer should either install the modules in a way that they will be well ventilated, B, keep the cables as long as possible, keep the tilt angle or the elevation angle of the PV modules less than 15 degrees. None of the other answers. So the right answer is install the modules in a way that they will be well ventilated. No, just if this well ventilated, the operating temperature is lower, so is the voltage is increased, and therefore the power output and the energy output of the whole system. Keep the cables as long as possible is wrong, because you have a higher resistance in the cable, and so the overall yield of the power plant will decrease. Also, for the tilt angle of the panels, depends on which side you are. Sure, if you are at the equator, it's good to keep the PV modules the horizontal. Even there you tilt it a little bit to allow the rain to clean the soiling. But here in Europe you should have the tilt angle in the vicinity of about 30 degrees or more. For example, if you want to generate more electricity during winter period, it's even better to have a higher elevation angle than 30 degrees. Second question, the maximum voltage occurs when there's a break in the circuit. Is it true or false? So what happens if there's a break in the circuit? Then the modules are operating close to the open circuit voltage. That means you have the highest voltage. So that is true. Deep discharge improves the life expectancy of lead acid battery. Is it true or false? So lead acid batteries, they are really sensible, so deep discharge and life expectancy is drastically reduced. So that's nonsense. So this is false. Maybe you have heard at nickel cadmium batteries or nickel hydride batteries that it's good to discharge them deeply for once in a while due to the memory effect, while they forget something about their real capacity. But first, you don't do it at every charge, you just do it once in a while, perhaps once a month or so. But it's not true for lead acid batteries. When sizing the cables, the permitted current rating of the cable should be at least equal or greater than the trigger current of the string fuse. Is that true or false? It's true. So you should protect the cables so they don't overheat, and the insulation will evaporate, and therefore you have to keep the fuse at a lower rating than the cable. The efficiency of string inverter ranges from 50 to 60%. That's totally nonsense. Nowadays, even string inverter module inverters are in the vicinity above 90% of conversion efficiency. Number 6, how does an inverter work? A is it converts AC voltage of the modules to a higher voltage of AC voltage. That's usually the task of a transformer. It converts DC voltage of the modules to AC voltage of the grid. Sounds more reasonable. It converts DC voltage of the modules to a higher DC voltage. That would be the task of a so-called DC-DC converter. It converts AC voltage of the modules to DC voltage of the grid. It's double nonsense. So the PV modules, they offer DC voltage and the grid is usually AC. It converts AC voltage of the modules to a higher AC voltage of the grid. So this is to a higher voltage. That's usually task of transformer as number A, and the modules, they don't offer AC voltage. They have DC voltage. So the answer is it converts DC voltage of the modules to AC voltage of the grid. That's a task of an inverter. Number 7, name 3 of the most common failures where PV system may lose energy. In brackets also give some explanation. A, shading. So shaded cells block the current of the entire string. Temperature decreased, therefore you have a reduced IMPP. Temperature increase, reduced open circuit voltage. Wrong orientation, that means a reduced irradiance of the panel. Short wiring, that increased resistance. So first, shading cells block the entire string, that's true. Temperature decrease, reduced IMPP. Yes, there is some reduction in maximum power point at lower temperature, but this effect is really small. The major effect is if you increase the temperature, you lose voltage and therefore power output, not only in open circuit voltage, but also in the voltage and maximum power point. Wrong orientation, yes, that reduces irradiance on the panel, and short wiring, that's nonsense. So if it's connected and the wires don't suffer any mechanical damage because due to different seasons and temperatures, and the mechanical strength will be too hard and they don't break, that's okay to keep the wires not as long as possible, but in the right size with some expansion and relatively short. So number 1 is correct. And temperature increase for reduced voltage, that's correct. Wrong orientation, that's also correct. These are the most common failures. We come to number 8. What is the role of a blocking, or sometimes we call it string diode, in a PV solar home system? Remember, we got some graphs on that, and there was a diode between the panel and the charge controller. The options are here. Blocking diodes protect the battery from discharge during nighttime. Blocking diodes break the electrical circuit if the load current is too high. Blocking diodes search for the best operating point of a PV module. So number 1 seems reasonable. So it's between the panel and the charge controllers, and if the battery is connected to the panel during nighttime, there might be some current flowing from the battery into the PV panel, and the blocking diode or string diode acts as a valve and inhibits the electricity going from the battery into the solar cell. So number 2, it's nonsense. You have a fuse for that, and the load current is in between the battery and the load, not between the PV panel and the charge controller. So that's nonsense. And number C, also because this task is carried out by the so-called maximum power point tracker, MPPT. Number 9. What happens to the performance ratio, or PR, of a PV power plant if the irradiance measurement is getting soiled? So there's dust accumulation on the pyranometer, for example. What happens? The first is you measure then a lower irradiance. You have another device where you measure the power output, and if you compare this two, you get the performance ratio. So the output divided by the input is your efficiency, and this relates to the performance ratio. And if the irradiance is lower than it actually is, and the output stays the same, you apparently have a higher PR. And so the options here, the resulting PR is lower than the real one, is wrong. The resulting PR is higher than the real one is true. And the resulting PR is not affected. That's not true. So the answer is B. who may be interested in the performance ratio: the module manufacturer, the investor and operator of the power plant. So the module manufacturer, he just gives the data sheet values, that is the performance under standard test conditions. That means at constant 1000 watt per square meter of irradiance, air mass of 1.5 for the spectrum, and a constant operation temperature of 25 degrees Celsius and perpendicular irradiance. So for him it doesn't matter because the module was measured when it came out of the factory, so he's not interested so much in the performance in the field. But the investor and operator is interested in the real performance on the field, and if the performance ratio is going down, he has to do countermeasures. So check the modules, check the cables, look for soiling of the modules and so on. And if he doesn't recognize there's something wrong due to the soiling of the irradiance device, he may delay some countermeasures, and that's not helpful for the overall yield of the power plant. So we come to question number 10. To specify the minimum technical requirements for BOS, that means balance of system costs of a PV system, for example, in order to set up a description for a tender, which requirements are necessary? A, the maximum voltage of the inverter input, the maximum current of the module strings and the inverter, the MPPT range of the inverter, the MPPT range of the modules under standard test conditions, the MPPT range of the modules at the expected operating conditions. So let's check which is true. So the maximum voltage for the inverter input is sure relevant if the modules are exceeding that that voltage. They may destroy the inverter, so for sure A. And the related question number E is for sure true. B, the maximum current of the module strings and the inverter, sure, you don't want to exceed the maximum current. Into the inverter may also lead to destruction of the inverter. The maximum power point tracking range of the inverter is also relevant. For example, if the voltage of the modules is too low and the modules are then operated with not within the range of the maximum power point, but without, you may lose some significant power output. The MPPT range of the modules at STC, it's not so relevant for the operation, but usually in the data sheet this is given then, and you should be able to compare them. So this is also a part of the description. So as a result, it's all true. Question number 11, which is the ambient temperature. Why is the ambient temperature at sunrise relevant for the layout? What happens at sunrise? The ambient temperature is lowest during daytime. So when first sun comes up, then we have some irradiance, not very large amount of irradiance, but the irradiance directly related to the current, but the voltage depends on the temperature. So at these conditions we have the highest voltage output, and this has to be digested by the inverter, and therefore this is relevant. Number 12. When and by whom a technical inspection of a PV power plant should be carried out? Should it be directly after commissioning? To the question, if you commission, you do these tests usually. Why should you do this after commissioning? So it doesn't make really sense. Directly before the end of the warranty period sounds more promising, because after the end of the warranty period you may not exchange some defect components for free. So this makes completely sense to do it before the end of the warranty period, and if you find some degradation, then you can exchange it for free. C. The inspections should be carried out by the EPC. Number D, the inspection should be carried out by an accredited independent entity. So if you have some claims against the manufacturer and so on, then from the juridical point of view, the EPC, he has a certain interest, so he installed the modules and so on. He is not independent. So therefore, the inspection should be carried out by an accredited independent entity. So this makes, especially if you have a very large-scale power plant, and so it's more easy to make claims against the manufacturer of some defectual devices. So B was correct, 1A was wrong, and D is correct also. That's it. Thank you very much for listening.